The MPLAB XC8 compiler's local code generation feature limits the extent to which some PIC-specific optimizations are applied to code. But what exactly does that mean, and why would you need to use this feature? Let's say you've developed a collection of routines. They have been built, packaged into a library and thoroughly tested. And now you want to make this library available for wider use in your company or for external customers to use in their own projects. In the case where end users of the library are using a regular compiler, which compiles each source module independently, any project they create can be optimized as they require, and the validated library is simply linked in after compilation, unmodified. This process, however, is a little different when using the XC8 compiler. The intermediate code contained in XC8 libraries is produced at an earlier stage in the compilation process, and the remainder of its compilation, which includes optimization, is performed when the library is made part of a project and that project is built. And since XC8 considers the entire program when optimizing, the effect of optimizations performed on library code will change, depending on the other code in the project. If this library contained validated code, generating assembly instructions that are different to that which were originally tested is usually not acceptable, and there must be some way to prevent this behavior. This is where local code generation is useful. To distribute validated code, you typically build and package the code as a library. If you have created a library project in the MPLAB X IDE, specify local code generation for that library by selecting the Project Properties, XC8 Compiler, Optimizations, Local Code Generation checkbox. If you are building on the command line, run the compiler using the -f local option and pass it all the source files to be included in the library. The intermediate files produced will contain information to indicate they were built with local code generation, and this information will propagate into the library when you run the archiver. The advantage of a validated library, even those built from just one source file, is that the local code generation specification for the library code will be carried into the end user's project and will automatically adjust the optimizations performed on that code. If you are developing source code, or you have obtained validated code that has been distributed as a single source file, you must inform the compiler that this code has to be built with local code generation. Enable it for just one file by right-clicking on its source file icon in the project's view and select Properties. In the dialog, enable Override Build Options. This reveals the compiler options that apply to just this file, and you can then enable the Optimizations Local Code Generation optimization. What defines code generation as being local? Internally, the compiler builds source code into groups, and these groups are encoded into the intermediate files and libraries produced by the compiler. Any source code compiled without local code generation is built into a default group. This group will always contain the standard library code supplied by the compiler, as it is always built with local code generation disabled. Source code that is compiled with the one command and that uses local code generation will be built into its own group. You can create more than one group by building source code with separate build commands, although this is typically not required. Provided they are built with one command, libraries allow the code in one or more source files to be contained in one group. When the internal groups are processed by the last stages of compilation to form the final program image, the optimizers can alter the assembly code produced by the default group in the usual way. Code in a library built with local code generation is also optimized, but the compiler will only use a subset of the usual optimizations, and any optimization that is dependent on code in another group is not permitted. Therefore, if the same library is compiled in a different project, the same optimizations will be applied to the library, even though the rest of the project might be optimized differently. In this way, optimizations are only performed local to a group, not across groups. To give you an example of how optimizations are made local, consider procedural abstraction optimizations. These transformations look in the built project for identical sequences of assembly instructions and replace these with calls to this same sequence that has been included just the once as a callable routine. If a library had been built using local code generation, procedural abstraction can still take place, but the assembly sequences are only considered identical if they are contained in the same group. Thus, procedural abstraction will take place on code within the default group, and it will independently take place on code within the library, but each group is considered in isolation. In this way, a library could be used by several projects, but the changes made by procedural abstraction to the library will be the same. Here is a summary of what optimizations are performed in each group. Optimizations like procedural abstraction, inlining of routines, p-sect merging, and p-pole optimizations are performed independently within each group. Other compiler features, however, are only performed in the default group, which means that in the local code generation groups, objects not specified with near will always be accessed as banked memory objects. Bank selection instructions are never removed. Page selection instructions always appear at the beginning and end of functions. Constant propagation is never performed, and pointer sizes are determined purely by their definition. This last point is covered in the next section. And finally, projects that contain any local code generation groups must be built using 32-bit float and double types. However, this is already a requirement when using the C99 language standard. Normally, pointer sizes are dependent on the target addresses that are assigned to the pointer, and that size can change as a project is modified. This creates a problem if any pointers in the local code generation group are assigned addresses by code in another group. This might occur if a function compiled with local code generation had a pointer parameter, and the function could be called from anywhere in the program. Pointer sizes when using local code generation are fixed, and the _RAM and _ROM pointer target specifiers ensure that the pointers cannot be assigned an address that would cause their size to change. When using local code generation, the compiler always considers a pointer to be in one of the following 4 pointer categories. Any const type pointer, which can be assigned the address of any data or program memory object, and which will have a fixed size of 2 or 3 bytes, depending on the target device. Any _ROM type pointer, the const qualifier is optional, which can be assigned the address of any program memory object, and which will have a fixed size of 2 or 3 bytes, depending on the target device. Any type pointer, which can be assigned the address of any data memory object, and which will have a fixed size of 2 bytes. Assigning the address of a const specified object to a pointer of this type will result in a warning as per the C standard, so there is a final category. Any _RAM type pointer, the const qualifier is optional, which can be assigned the address of any data memory object, including those specified as const, and which will have a fixed size of 2 bytes. If you attempt to assign the address of an incompatible object to a pointer, an error will be issued by the compiler, thus ensuring that the pointer's size cannot change from that originally intended. Although the MPLAB XC8 compiler automatically controls many aspects of how a project is built for 8-bit PIC devices, using local code generation with the library tells the compiler to keep its optimizing hands off, so that the library's contribution to the final program image will not change from that originally validated, regardless of the code it is built with.